Question 1. The assessment process reveals a critical application is failing to start on a Linux server. The technician suspects a misconfiguration in a specific system file located within the /etc/appname/ directory. The technician needs to verify the file's contents to diagnose the issue. Which sequence of CLI commands would be the most appropriate and least disruptive first step to investigate the suspected configuration file? Option A. Use rm to delete the suspected configuration file to force the application to recreate it with default settings. Option B. Use cp to copy the suspected configuration file to /tmp/ for examination. Option C. Use pwd to confirm the current directory, then ls to list files, and finally nano to open and view the suspected configuration file. Option D. Use mv to rename the suspected configuration file to config. Back to create a backup before investigating. Correct answer is C. Use pwd to confirm the current directory, then ls to list files, and finally nano to open and view the suspected configuration file. Explanation. This scenario is professionally challenging because it involves a technician needing to access and potentially modify sensitive system configuration files without explicit authorization, which could lead to security breaches or system instability. The core of the challenge lies in balancing the need for troubleshooting with adherence to established security protocols and data privacy regulations. The correct approach involves using the pwd command to confirm the current directory, and then the ls command to list files, followed by nano or Roman 6 to view the configuration file content. This method is correct because it prioritizes understanding the environment and the specific file before making any changes. It aligns with CompTIA plus principles of methodical troubleshooting and respecting system integrity. While CompTIA plus doesn't enforce specific U.S. regulations, the underlying ethical principles of responsible IT practice, which are implicitly tested, dictate minimizing risk and avoiding unauthorized access or modification. This approach ensures the technician knows exactly where they are and what they are looking at, reducing the chance of accidental data corruption or exposure. An incorrect approach of immediately using mv to rename the configuration file is wrong because it constitutes an unauthorized modification of a critical system file without understanding its purpose or impact. This action could render the system inoperable and violates the principle of least privilege and responsible system administration. Another incorrect approach of using rm to delete the configuration file is even more severe. This is a destructive action that would likely cause significant system failure and data loss, representing a gross violation of professional IT conduct and potentially leading to data breaches if the file contained sensitive information. A further incorrect approach of using cp to copy the configuration file to a publicly accessible directory without proper sanitization or authorization is also professionally unacceptable. This action could expose sensitive system information to unauthorized parties, creating a significant security vulnerability and violating data privacy best practices. The professional decision-making process for similar situations should involve a clear understanding of the problem, followed by a systematic approach to gathering information. This includes confirming the current location, pwd, identifying relevant files, ls, and then, if necessary and authorized, making precise, controlled modifications using appropriate tools like text editors, nano, Roman 6. Always prioritize understanding and minimizing risk before taking any action that alters system state. Question 2. Market research demonstrates that a small business is looking to deploy a new file server. The business has a limited IT budget, but requires a stable and secure platform for storing sensitive client documents. They have a small team with some general IT knowledge, but no dedicated server administrators. Which of the following approaches best aligns with professional best practices for selecting a server operating system in this context, considering U.S. regulatory and licensing frameworks? Option A. Deploy a free, community-supported Linux distribution without a formal support contract, relying solely on online forums for troubleshooting and security updates. Option B. Choose the cheapest Windows Server license available and install it with default security settings, assuming that the built-in features will be sufficient for basic file sharing. Option C. Opt for a server operating system that is familiar to the IT team, even if it requires significant customization to meet the specific needs of a file server, to minimize training costs. Option D. Select a widely adopted enterprise-grade Linux distribution that offers robust security features and extensive community support, and plan for a phased implementation of commercial support if budget allows in the future. The correct answer is D. Select a widely adopted, enterprise-grade Linux distribution that offers robust security features and extensive community support, and plan for a phased implementation of commercial support if budget allows in the future. Explanation: this scenario presents a common challenge in IT infrastructure management, selecting the most appropriate server operating system for a new deployment. The professional challenge lies in balancing cost, performance, security, and compatibility with existing infrastructure and future needs, all while adhering to the specific regulatory and licensing frameworks relevant to the CompTIA, a plus exams jurisdiction, which is primarily US-based for general IT certifications, unless otherwise specified. Careful judgment is required to avoid costly mistakes, security vulnerabilities, and non-compliance. The correct approach involves a thorough evaluation of the organization's specific requirements, including application compatibility, existing hardware, user expertise, and budget. For a US-based organization, this would involve considering the licensing models of Windows Server, e.g., per core, CAL, and the support structures available for Linux distributions, e.g., enterprise support from Red Hat or SUSE, or community support for Debian/Ubuntu. Prioritizing security best practices, such as regular patching and access control, is paramount. Compliance with relevant U.S. data privacy regulations, like HIPAA for healthcare or PCI DSS for payment card data, if applicable, would also be a critical factor in the decision-making process, influencing the choice of OS and its configuration. An incorrect approach would be to solely prioritize the lowest initial cost, without considering long-term support, security updates, or licensing implications. For instance, choosing a free Linux distribution without a clear plan for enterprise-level support could lead to significant downtime and security risks if critical vulnerabilities are discovered and not promptly addressed. This failure to plan for ongoing maintenance and security is a significant ethical and professional lapse, as it jeopardizes the stability and integrity of the organization's IT systems. Another incorrect approach would be to select an operating system based purely on familiarity or personal preference, without a systematic evaluation of its suitability for the intended server roles and the organization's overall IT strategy. This can lead to compatibility issues with essential business applications, increased training costs, and a less efficient IT environment. Furthermore, ignoring the licensing requirements of commercial operating systems like Windows Server can result in legal and financial penalties for noncompliance, a critical regulatory failure. A third incorrect approach would be to deploy a server operating system without implementing robust security measures from the outset. This includes neglecting to configure firewalls, implement strong authentication, or establish a regular patching schedule. Such oversights create significant security vulnerabilities, exposing the organization to data breaches and cyber attacks, which can have severe legal and financial repercussions under U.S. data protection laws. The professional decision-making process should involve a structured needs assessment, followed by a comparative analysis of potential OS solutions against defined criteria. This includes evaluating licensing costs, support availability, security features, application compatibility, and the availability of skilled personnel. Documenting the decision-making process and the rationale behind the chosen OS is also a crucial professional practice, ensuring transparency and accountability. Question 3. Strategic planning requires a technician to upgrade the RAM in a user's workstation to improve performance. The technician has identified several RAM modules, but before proceeding with the installation, what is the most critical step to ensure system stability and data integrity? Option A. Purchase the RAM module with the highest capacity, as more memory is always better for performance. Option B. Install RAM from any manufacturer, as long as it physically fits into the slot. Option C. Install the fastest RAM module available to maximize performance gains. Option D. Verify the new RAM's compatibility with the motherboard and CPU, and ensure it meets the system's speed and capacity specifications. The correct answer is D. Verify the new RAM's compatibility with the motherboard and CPU, and ensure it meets the system's speed and capacity specifications. Explanation: this scenario is professionally challenging because it involves balancing the immediate need for system performance with the long-term implications of hardware choices, particularly concerning data integrity and potential security vulnerabilities. A technician must consider not only the technical specifications of RAM, but also its compatibility and the potential risks associated with using unverified or substandard components. Careful judgment is required to avoid introducing instability or security risks that could compromise user data or system functionality. The correct approach involves verifying the compatibility of the new RAM with the existing motherboard and CPU, and ensuring it meets the system specifications for speed and capacity. This is crucial because incompatible RAM can lead to system instability, data corruption, and even hardware failure. Furthermore, using RAM from reputable manufacturers with proper specifications helps mitigate risks associated with counterfeit or faulty components, which could have security implications if they contain malicious firmware or are prone to failure that exposes sensitive data. While the CompTIA Plus exam focuses on technical knowledge, the underlying principle is to ensure system reliability and data integrity, which are foundational to professional IT practice. An incorrect approach that involves installing the fastest available RAM without checking compatibility is professionally unacceptable. This directly violates the principle of ensuring system stability and can lead to immediate operational issues, data loss, and potentially costly hardware damage. It demonstrates a lack of due diligence and a disregard for the fundamental requirements of hardware integration. Another incorrect approach: installing RAM that is not from a reputable manufacturer or is of unknown origin introduces significant risks. While it might seem like a cost-saving measure, it bypasses quality control and testing standards. This can lead to premature failure, performance issues, and, in worst-case scenarios, could potentially introduce security vulnerabilities if the RAM has been tampered with or is designed to be unreliable in a way that could expose data. This approach fails to uphold the professional responsibility to maintain secure and reliable systems. A third incorrect approach: prioritizing the highest capacity RAM regardless of speed or compatibility, is also professionally unsound. While more capacity can be beneficial, if it is not compatible with the motherboard or is significantly slower than the existing RAM, it can create a bottleneck, reducing overall system performance. This demonstrates a superficial understanding of system optimization and ignores the interconnectedness of hardware components. Professionals should employ a systematic decision-making process that begins with understanding the system's requirements and limitations. This involves consulting documentation, checking compatibility lists, and considering the intended use of the system. When selecting hardware, prioritizing reliability, compatibility, and adherence to specifications from reputable sources is paramount. This ensures that the implemented solution is stable, secure, and performs as expected, thereby upholding professional standards and client trust. Question 4. The audit findings indicate that several workstations are failing to boot into the operating system, displaying an error message related to an untrusted boot image. The IT technician needs to resolve this issue efficiently and securely, adhering to best practices for system integrity. Which of the following actions should the technician prioritize to address the untrusted boot image error? Option A. Update all device drivers for the workstation's hardware components. Option B. Reinstall the operating system on the affected workstations without further investigation into the boot sequence. Option C. Verify the integrity of the UEFI firmware settings, specifically checking for the correct configuration of Secure Boot and ensuring that the bootloader is digitally signed by a trusted authority. Option D. Disable Secure Boot within the UEFI settings to allow the system to boot with any bootloader. The correct answer is C. Verify the integrity of the UEFI firmware settings, specifically checking for the correct configuration of Secure Boot and ensuring that the bootloader is digitally signed by a trusted authority. Explanation: the audit findings indicate a potential security vulnerability related to the operating system's boot process. This scenario is professionally challenging because a compromised boot process can undermine the entire security posture of a system, allowing unauthorized access or malicious code execution before the operating system's security controls are fully active. Careful judgment is required to identify the root cause and implement the correct remediation without disrupting critical operations. The correct approach involves verifying the integrity of the UEFI firmware settings and ensuring that the bootloader is correctly signed and validated. This is crucial because UEFI, as the modern replacement for BIOS, provides enhanced security features like Secure Boot, which cryptographically verifies the authenticity of boot components. By ensuring these components are trusted, the system prevents the loading of unauthorized operating systems or malicious bootkits. This aligns with general IT best practices for system security and integrity, which are implicitly expected in professional IT environments, even without specific CompTIA, A+ regulations dictating exact UEFI configurations. The focus is on establishing a trusted chain of execution from the moment the hardware powers on. An incorrect approach would be to simply reinstall the operating system without investigating the boot process. This fails to address the potential underlying issue within the UEFI or bootloader, meaning the vulnerability could persist or reappear. It also represents a failure to perform thorough diagnostics, which is a core professional responsibility. Another incorrect approach would be to disable Secure Boot in UEFI settings. While this might allow a system to boot with unsigned or custom bootloaders, it fundamentally compromises the security intended by Secure Boot and opens the system to boot-level malware. This directly contradicts the principle of maintaining system integrity and security. A further incorrect approach would be to only update the operating system's drivers. While driver updates are important for system stability and performance, they are typically loaded after the initial boot process has successfully completed. This approach would not address any issues occurring during the early stages of booting, such as problems with the UEFI firmware or the bootloader itself. The professional reasoning framework for such situations involves a systematic diagnostic process. First, understand the reported issue and its potential impact. Second, consult documentation and knowledge bases for known issues and best practices related to the specific hardware and operating system. Third, perform targeted diagnostics, starting with the earliest stages of the boot process, UEFI/BIOS, bootloader, and progressing sequentially. Fourth, implement solutions based on diagnostic findings, prioritizing security and system integrity. Finally, verify the fix and document the process. Question 5. The assessment process reveals that a user's mobile device is experiencing performance issues, and the technician suspects that a recently installed application might be the cause. To confirm this, the technician would need to review the device's running processes and potentially its data logs. What is the most appropriate course of action to take regarding the user's privacy and data? Option A. Obtain explicit, informed consent from the user before accessing any application data or system logs that might contain personal information. Option B. Wipe the device and reinstall the operating system to ensure a clean slate and resolve the performance issues. Option C. Proceed with the analysis of running processes and data logs immediately, as it is necessary for troubleshooting and improving device performance. Option D. Ask a senior technician to perform the analysis without informing the user about the specific data that will be accessed. The correct answer is A. Obtain explicit, informed consent from the user before accessing any application data or system logs that might contain personal information. Explanation. This scenario presents a professional challenge because it requires balancing user privacy with the need for security and operational efficiency within the constraints of a specific regulatory framework. The technician must make a judgment call that could impact both the user's data and the organization's compliance posture. Careful consideration of the applicable laws and guidelines is paramount. The correct approach involves obtaining explicit, informed consent from the user before accessing or analyzing their personal data on a mobile device, even for troubleshooting purposes. This aligns with the principles of data privacy and user autonomy. In the context of the CompTIA A+ exam, which often implicitly references general best practices and common legal principles found in many jurisdictions, though not explicitly tied to a single country's specific laws unless stated. This approach upholds the ethical obligation to respect user privacy and avoid unauthorized access to personal information. The underlying principle is that individuals have a right to control their data, and any deviation from this requires their clear permission. An incorrect approach would be to proceed with the analysis without user consent, assuming it is necessary for troubleshooting. This violates the fundamental principle of user privacy and could lead to legal repercussions if the data accessed is sensitive or confidential. It demonstrates a lack of respect for user autonomy and a failure to adhere to ethical standards regarding data handling. Another incorrect approach would be to immediately wipe the device to fix the issue without attempting to diagnose the problem or consult the user. This is a destructive and unprofessional response that disregards the user's data and potential loss of important information. It fails to address the root cause of the problem and is an overreaction that could have severe consequences for the user. A further incorrect approach would be to delegate the task to another technician without proper documentation or oversight. While collaboration can be beneficial, bypassing the proper consent process or failing to ensure the task is handled ethically and competently by the delegated individual is a failure in professional responsibility. It can lead to inconsistent practices and potential breaches of privacy or security. The professional reasoning process for similar situations should involve a clear understanding of the organization's policies regarding data privacy and device access, as well as general ethical guidelines. When faced with a situation requiring access to user data, the technician should first attempt to resolve the issue without accessing personal information. If access is unavoidable, the technician must clearly explain the necessity to the user, obtain their explicit and informed consent, and document the interaction. If consent cannot be obtained, the technician should explore alternative solutions or escalate the issue to a supervisor or the appropriate department. Question 6. Compliance review shows a user reporting significant slowdowns and unresponsiveness on their workstation. The technician needs to diagnose the issue efficiently. Which of the following approaches best aligns with the principles of operating system core function management for process optimization? Option A. Assume the hard drive is failing and proceed with replacing the storage device without further investigation. Option B. Examine active processes for resource hogs, then review memory utilization and paging activity, followed by checking file system integrity and disk I/O, and finally inspecting device manager for errors. Option C. Focus solely on checking the network connection and firewall settings, as slow performance is often network-related. Option D. Immediately initiate a full system backup and then proceed with a clean installation of the operating system. The correct answer is D. Immediately initiate a full system backup and then proceed with a clean installation of the operating system. Explanation. Scenario analysis. This scenario presents a common challenge in IT support where a user reports performance degradation. The professional challenge lies in diagnosing the root cause efficiently and effectively, while adhering to best practices for operating system management and ensuring user productivity is restored with minimal disruption. The need for careful judgment arises from the potential for misdiagnosis, leading to unnecessary troubleshooting steps, system instability, or even data loss if incorrect actions are taken. Furthermore, understanding the core functions of process, memory, file system, and device management is crucial for accurate problem identification. Correct approach analysis. The correct approach involves systematically investigating the operating system's core functions to identify the bottleneck. This begins with examining active processes to see if any are consuming excessive resources, CPU memory, which directly relates to process management. If processes appear normal, the next step is to review memory usage, checking for high utilization or excessive paging, which falls under memory management. Following this, assessing file system performance and integrity, including disk I/O and fragmentation, is key to file system management. Finally, checking device manager for any errors or driver issues addresses device management. This methodical, layered approach ensures that all critical OS functions are considered in a logical order, increasing the likelihood of pinpointing the actual cause of the performance issue without introducing new problems. This aligns with the CompTIA, a plus focus on understanding how these core OS functions interact and contribute to overall system performance. Incorrect approach is analysis. One incorrect approach is to immediately assume a hardware failure and begin replacing components without first diagnosing the software or OS-level issues. This is inefficient, costly, and ignores the fundamental OS core functions that could be the source of the problem. It represents a failure in systematic troubleshooting and a disregard for the principles of process, memory, and file system management. Another incorrect approach is to only focus on one aspect of OS management, such as solely looking at running processes and ignoring memory, file system, or device issues. This narrow focus can lead to a misdiagnosis if the performance bottleneck lies elsewhere. For instance, A system might appear to have normal process activity, but severe memory leaks or a failing hard drive could still cause significant slowdowns. This demonstrates a lack of comprehensive understanding of how all core OS functions are interconnected. A third incorrect approach is to perform a system-wide reset or reinstallation of the operating system as the first step. While this can resolve many issues, it is a drastic measure that leads to significant data loss and downtime for the user. It bypasses the diagnostic process and fails to apply the principles of efficient troubleshooting and understanding of core OS functions. This approach is unprofessional as it prioritizes a quick fix over a targeted solution and demonstrates a lack of skill in diagnosing and resolving issues at the OS level. Professional reasoning. Professionals should adopt a systematic, layered troubleshooting methodology. This involves understanding the user's reported symptoms, then logically progressing through the core functions of the operating system: process management, memory management, file system management, and device management. Each layer should be investigated for anomalies before moving to the next. This approach minimizes unnecessary steps, reduces the risk of introducing new problems, and ensures that the most likely causes are addressed first. Documenting findings at each stage is also crucial for tracking progress and for future reference. Question 7. Risk assessment procedures indicate that a small business's critical customer relationship management (CRM) application requires high read and write performance, as well as robust protection against data loss due to drive failure. The IT technician is evaluating different RAID configurations to meet these demands within a reasonable budget. Which RAID level would best satisfy the stated requirements for both performance and redundancy? Option A, RAID 10 1+0. Option B, RAID 5. Option C, RAID 1. Option D, RAID 0. Correct answer is A, RAID 10 1+0. Explanation. Scenario analysis. This scenario presents a common challenge in IT support where a client requires a specific level of data redundancy and performance for a critical application, but has budget constraints. The challenge lies in balancing these competing needs while ensuring compliance with general IT best practices for data integrity and availability, which are implicitly expected in a professional CompTIA A+ context. The technician must understand the trade-offs of different RAID levels to recommend the most suitable solution without overpromising or underdelivering. Correct approach analysis. The correct approach involves recommending RAID 10 1+0. This is because RAID 10 offers a strong balance of performance and redundancy. It achieves this by striping data across mirrored pairs, providing fault tolerance for at least one drive failure per mirrored set, and excellent read/write speeds due to striping. In a professional IT context, especially when dealing with critical applications, this level of protection and performance is often a standard expectation for ensuring business continuity and data availability, aligning with general principles of responsible IT management and client service. While no specific U.S. regulation directly mandates RAID levels, the expectation of providing reliable and resilient systems for business operations is a core professional responsibility. Incorrect approaches analysis. Recommending RAID 0 would be an incorrect approach because it offers no redundancy. While it provides excellent performance through striping, a single drive failure would result in complete data loss. This directly contradicts the requirement for data protection and is professionally unacceptable for any critical application. Recommending RAID 5 would be an incorrect approach because, while it offers redundancy through parity, its write performance can be significantly slower than RAID 10 due to the overhead of calculating and writing parity data. Furthermore, in the event of a single drive failure, the array is vulnerable during the rebuild process. If another drive fails during the rebuild, data loss will occur. This makes it less suitable for applications requiring high write performance and immediate availability. Recommending RAID 1 would be an incorrect approach because, while it offers excellent redundancy through mirroring, it does not offer the performance benefits of striping that RAID 10 provides. For an application that requires both speed and reliability, RAID 1 alone might not meet the performance expectations, making it a less optimal solution compared to RAID 10. Professional reasoning. Professionals should approach such scenarios by first thoroughly understanding the client's specific requirements, including performance needs, acceptable downtime, and budget. Then, they should evaluate the available RAID levels based on their technical characteristics, performance, redundancy, cost, complexity. The decision-making process involves mapping these characteristics to the client's needs, prioritizing data integrity and availability, and then selecting the RAID level that offers the best overall fit. This analytical process ensures that the recommended solution is technically sound, meets business objectives, and upholds professional standards of service. Question 8. Upon reviewing a user's report of significant system slowdowns and unresponsiveness, particularly during multitasking and demanding applications, a technician suspects a potential issue with the Central Processing Unit, CPU. What is the most appropriate initial diagnostic step to assess the CPU's impact on performance? Option A. Immediately recommend replacing the CPU, as it is the most critical component for system speed. Option B. Focus on optimizing background applications and uninstalling unnecessary software to free up system resources. Option C. Reinstall the operating system to rule out software corruption as the cause of the slowdown. Option D. Check the CPU's operating temperature and ensure adequate cooling, as overheating can cause thermal throttling and reduce performance. The correct answer is D. Check the CPU's operating temperature and ensure adequate cooling, as overheating can cause thermal throttling and reduce performance. Explanation. This scenario presents a professional challenge because a technician is tasked with diagnosing a performance issue on a user's computer, and the root cause is suspected to be related to the Central Processing Unit, CPU. The technician must apply their knowledge of hardware components and their impact on system performance within the context of the CompTIA, a plus exam scope, which focuses on foundational IT knowledge and best practices. The challenge lies in accurately identifying the CPU's role in performance degradation and distinguishing it from other potential causes, all while adhering to the principles of effective troubleshooting. The correct approach involves systematically evaluating the CPU's health and performance characteristics. This includes checking for thermal throttling due to overheating, ensuring the CPU is properly seated, and verifying that the operating system and BIOS/UEFI are configured to allow the CPU to operate at its intended speeds. This approach is correct because it directly addresses the most common CPU-related performance bottlenecks. CompTIA, a plus, emphasizes a logical troubleshooting methodology, and this approach aligns with that by starting with the most probable hardware component and its direct operational factors. An incorrect approach would be to immediately assume the CPU is faulty and recommend replacement without proper diagnosis. This is professionally unacceptable because it bypasses essential diagnostic steps, leading to unnecessary expense and downtime for the user. It fails to consider that performance issues can stem from software conflicts, insufficient RAM, or storage bottlenecks, all of which might mimic CPU-related symptoms. Another incorrect approach is to focus solely on software solutions, such as reinstalling the operating system, without first verifying the integrity and proper functioning of the core hardware components like the CPU. While software can impact performance, a fundamentally sound hardware base is a prerequisite for optimal operation. This approach fails to acknowledge the direct impact of hardware on system responsiveness. Professionals should employ a structured troubleshooting process. This involves gathering information about the symptoms, forming a hypothesis, testing the hypothesis through systematic diagnostics, implementing a solution, verifying the fix, and documenting the process. When dealing with potential CPU issues, this means checking temperatures, ensuring proper cooling, verifying BIOS settings, and observing system behavior under load before concluding that the CPU itself is the faulty component. Question 9. The risk matrix shows a potential performance bottleneck if a new high-speed network interface card (NIC) is installed in an older workstation. The workstation motherboard has available slots for PCI, AG, and PCIe. The NIC is designed for modern network speeds and requires significant bandwidth. Which expansion slot should be prioritized for installing the new NIC to mitigate the identified performance bottleneck? Option A, PCI slot. Option B, any available slot, as they all serve the same purpose for expansion cards. Option C, AGP slot. Option D, PCIe slot. The correct answer is D, PCIe slot. Explanation. This scenario presents a common challenge in hardware upgrades where a technician must balance performance needs with compatibility and cost, all while adhering to established best practices and potentially manufacturer guidelines. The professional challenge lies in identifying the most appropriate expansion slot technology for a given upgrade scenario, considering the limitations and capabilities of legacy and modern interfaces. Careful judgment is required to avoid introducing performance bottlenecks or compatibility issues that could negatively impact system stability and user experience. The correct approach involves selecting the expansion slot technology that offers the best balance of performance, compatibility, and future-proofing for the intended upgrade. This means understanding the bandwidth differences between PCIe, PCI, and AGP, and matching the slot to the requirements of the new hardware. For instance, if a high-performance graphics card is being installed, a PCIe slot is the only viable option due to its significantly higher bandwidth compared to PCI. If a legacy sound card or network adapter is being added to an older system, a PCI slot might be the most appropriate and cost-effective choice. AGP, being a legacy slot primarily for graphics, would only be considered in very specific, older system upgrade scenarios and is generally superseded by PCIe. An incorrect approach would be to assume all expansion slots are interchangeable. For example, attempting to install a modern graphics card into a PCI slot would fail due to insufficient bandwidth and physical incompatibility. Similarly, installing a high-bandwidth PCIe device into a PCI slot would result in severe performance limitations, rendering the device ineffective. Ignoring the specific requirements of the hardware being installed and the capabilities of the available expansion slots leads to suboptimal system performance, potential hardware damage, and wasted resources. Professionals should approach such decisions by first identifying the specific hardware to be installed and its interface requirements. Then they should assess the available expansion slots on the motherboard, noting their type PCIe, PCI, AGP, and generation e.g. PCIe 3, 0, PCIe 4, 0. Finally, they should match the hardware requirements to the most suitable and performant slot available, considering any potential bottlenecks. This systematic process ensures that upgrades are performed correctly, efficiently, and with optimal results. Question 10. The efficiency study reveals that the current workstation is experiencing significant performance degradation, impacting user productivity. The user requires a new operating system installation to improve performance and ensure compatibility with updated software. The technician is considering several installation methods to address these findings. Which installation method best aligns with the study's findings and professional best practices for ensuring optimal system performance and data integrity? Option A. Restore a system image from a previous backup onto the new operating system. Option B. Perform a clean install of the new operating system. Option C. Attempt an in-place upgrade from the current operating system to the new one. Option D. Configure a dual boot setup with the new operating system alongside the old one. Correct answer is B. Perform a clean install of the new operating system. Explanation. This scenario presents a professional challenge because it requires balancing user needs for data preservation with the technical requirements of a new operating system installation, all while adhering to the strict guidelines of the CompTIA, a plus exams assumed regulatory framework, which emphasizes data integrity, user privacy, and efficient resource utilization. The technician must make a judgment call that impacts the user's workflow and data security. The correct approach involves performing a clean install. This is the most professionally sound method because it ensures a fresh, uncorrupted operating system environment, minimizing the risk of compatibility issues, performance degradation, or security vulnerabilities that could arise from an upgrade or dual booting on an older, potentially unstable system. From a regulatory and ethical standpoint, a clean install aligns with the principle of providing a secure and reliable computing environment, protecting the user's data by starting from a known good state. It also demonstrates due diligence in ensuring the system meets the performance benchmarks identified in the efficiency study. Forming an upgrade is an incorrect approach because it carries a significant risk of inheriting existing problems from the old operating system, potentially leading to instability and performance issues that contradict the efficiency study's findings. This could result in a system that does not meet the user's expectations or the study's objectives, potentially leading to a breach of service-level agreements or user dissatisfaction, which can have ethical implications regarding professional competence and client trust. Implementing a dual boot configuration is also an incorrect approach in this context. While it preserves existing data, it introduces complexity and potential for user error in selecting the correct operating system at boot. More importantly, it may not fully address the performance bottlenecks identified in the efficiency study, as the underlying hardware might still be strained by running two operating systems. Furthermore, managing security updates and potential conflicts between two operating systems can increase the risk of vulnerabilities, which is a failure in maintaining a secure computing environment. Professionals should approach such situations by first understanding the core objectives of the efficiency study and the user's primary needs. They should then evaluate each installation method against these objectives, considering potential risks and benefits. A risk assessment matrix, even if not explicitly calculated, should guide the decision-making process, prioritizing data integrity, system stability, security, and performance. When in doubt, consulting with the user about the trade-offs and obtaining explicit consent for the chosen method is crucial for maintaining professional integrity and client satisfaction. Question 11. Examination of the data shows that a user is reporting significantly slow application loading times, prolonged system boot-up sequences, and sluggish file transfer speeds. The user's current system utilizes a traditional hard disk drive, HDD, for its operating system and primary applications. Based on these symptoms and the current hardware configuration, which of the following approaches would most effectively address the user's performance concerns? Option A. Upgrade the system's random access memory RAM. Option B. Replace the existing hard disk drive HDD with a new, larger capacity HDD. Option C. Replace the existing hard disk drive HDD with a solid-state drive SSD. Option D. Add a secondary hard disk drive HDD to the system. The correct answer is C. Replace the existing hard disk drive HDD with a solid-state drive SSD. Explanation. Scenario analysis. This scenario presents a common challenge in IT support where a user experiences performance degradation with their storage. The professional challenge lies in accurately diagnosing the root cause and recommending the most appropriate solution, balancing cost, performance, and user needs, all while adhering to the principles of responsible IT practice as outlined by CompTIA, A+ guidelines. The need for a swift yet accurate resolution is paramount to minimize user downtime and maintain productivity. Correct approach analysis. The correct approach involves understanding the fundamental differences in performance characteristics between HDDs and SSDs. HDD, with their mechanical spinning platters, are inherently slower for random read/write operations compared to SSDs, which use flash memory. If the user system is experiencing slow application loading, boot times, and file transfers, especially with frequently accessed data, a failing HDD or simply the inherent limitations of HDD technology are strong possibilities. Upgrading to an SSD would directly address these performance bottlenecks by providing significantly faster data access. This aligns with CompTIA, A+ principles of recommending hardware upgrades that demonstrably improve system performance and user experience based on the observed symptoms. Incorrect approach is analysis. Replacing the HDD with another HDD, even a larger or faster model, may not yield the dramatic performance improvement expected if the primary bottleneck is the mechanical nature of the drive. While it might offer some improvement, it fails to leverage the significant speed advantage of modern storage technologies and may not fully resolve the user's perceived performance issues, leading to potential dissatisfaction and a need for further intervention. Upgrading the RAM would address system responsiveness issues related to multitasking or running memory-intensive applications, but it would not directly improve the speed of data access from the storage device itself. If the primary complaint is slow loading of applications or files, RAM is unlikely to be the sole or primary solution. Adding a secondary HDD without replacing the primary one would increase storage capacity, but would not inherently speed up the operating system or frequently used applications if they remain on the original, slower drive. This approach addresses storage space concerns rather than performance bottlenecks related to data access speed. Professional reasoning. Professionals should approach such situations by first gathering detailed information about the user's symptoms and usage patterns. This involves asking clarifying questions about what specific tasks are slow, when the slowness occurs, and any recent changes to the system. Based on this information, they should then consider the most likely hardware components contributing to the observed issues. For storage-related performance problems, understanding the differences between HDD and SSD technology is crucial. The decision-making process should prioritize solutions that directly address the identified bottleneck and offer the most significant improvement in user experience, while also considering cost-effectiveness and the user's budget. This involves a systematic evaluation of potential hardware failures or limitations and matching them to appropriate upgrade or replacement strategies. Question 12. Assessment of the most effective hardware component replacement strategy for a user experiencing intermittent system freezes and slow performance on a workstation, given that initial observations suggest a potential issue with the primary storage device. Option A. Run comprehensive diagnostic tests on the primary storage device and other key hardware components to identify the root cause of the performance issues before replacing any parts. Option B. Immediately replace the primary storage device with a new, higher-capacity solid-state drive, SSD, that is compatible with the system's motherboard. Option C. Install additional RAM to see if that resolves the freezing, as RAM issues can sometimes manifest as storage-related symptoms. Option D. Reformat the primary storage device and reinstall the operating system, assuming the performance issues are software-related. The correct answer is B. Immediately replace the primary storage device with a new, higher-capacity solid-state drive, SSD, that is compatible with the system's motherboard. Explanation. This scenario presents a common challenge in IT support, balancing the need for immediate system functionality with the long-term health and security of hardware. Professionals must make informed decisions about component replacement that consider not only performance, but also potential risks and compliance with industry best practices, which are implicitly guided by the principles of the CompTIA framework. The challenge lies in identifying the root cause of performance degradation and selecting the most appropriate solution without introducing new vulnerabilities or violating implicit guidelines for responsible hardware management. The correct approach involves a systematic diagnostic process to pinpoint the failing component, and then selecting a replacement that meets or exceeds the original specifications, prioritizing reliability and compatibility. This aligns with the CompTIA emphasis on methodical troubleshooting and understanding hardware life cycles. By performing diagnostics, the technician ensures they are addressing the actual problem, not just a symptom. Choosing a compatible and reliable replacement component is crucial for system stability and preventing future issues, reflecting a commitment to professional standards of care. An incorrect approach of simply replacing the most suspected component without thorough diagnostics fails to address the root cause and could lead to misdiagnosis, wasted resources, and continued performance problems. This bypasses the fundamental troubleshooting methodology taught in CompTIA and can result in a suboptimal fix. Another incorrect approach, replacing a component with a significantly older or lower specification part, compromises system performance and potentially introduces instability or security vulnerabilities, violating the principle of maintaining system integrity. Finally, recommending a complete system overhaul when a single component is failing is an inefficient and costly solution that does not demonstrate a thorough understanding of hardware diagnostics and component-level repair, which are core competencies for certified professionals. Professionals should approach such situations by first adhering to a structured troubleshooting methodology. This involves gathering information, forming a hypothesis, testing the hypothesis through diagnostics, and then implementing a solution based on the test results. The decision-making process should prioritize the most efficient and effective resolution that ensures system stability, security, and longevity, always considering the impact on the user and the organization. Question 13. Which approach would be the most professional and effective for managing operating system updates, security patches, feature updates, and driver updates on a diverse network of user workstations? Option A. Deploy all operating system updates and security patches to all workstations during business hours, and then individually address driver updates as users report issues. Option B. Implement a phased rollout of security patches and feature updates, starting with a pilot group, and manage driver updates based on critical security vulnerabilities or stability issues after thorough testing. Option C. Immediately deploy all available security patches, feature updates, and driver updates to all workstations as soon as they are released to ensure maximum security. Option D. Defer all operating system updates, security patches, and driver updates until a major system overhaul is scheduled to avoid any potential disruption to users. The correct answer is B. Implement a phased rollout of security patches and feature updates, starting with a pilot group, and manage driver updates based on critical security vulnerabilities or stability issues after thorough testing. Explanation: this scenario presents a common challenge in IT support, balancing the need for security and functionality with potential disruption to end users. The professional challenge lies in implementing necessary operating system updates and patches without causing significant downtime or compatibility issues, while adhering to best practices for system integrity and user productivity. Careful judgment is required to select an update strategy that minimizes risk and maximizes benefit. The correct approach involves a phased rollout of security patches and feature updates, starting with a pilot group of non-critical systems. This allows for testing of compatibility and functionality in a controlled environment before wider deployment. Driver updates should be managed separately, focusing on critical security vulnerabilities or known stability issues, and deployed after thorough testing, ideally during scheduled maintenance windows. This strategy aligns with the CompTIA A+ focus on proactive maintenance and risk mitigation. While specific regulations are not detailed in the CompTIA A+ framework, the underlying principle is to maintain system security and operational integrity, which are implicitly expected in professional IT practice. This phased approach minimizes the risk of widespread system failure or data loss, thereby protecting the organization's assets and user productivity. An approach that immediately deploys all available updates to all systems without prior testing is professionally unacceptable. This could lead to widespread system instability, application incompatibility, and significant downtime, directly impacting user productivity and potentially causing data corruption. It fails to adhere to the principle of controlled change management. Another incorrect approach is to defer all updates indefinitely, citing potential disruption. This creates significant security vulnerabilities by leaving systems exposed to known exploits, which is a direct failure of professional responsibility to maintain system security. Finally, deploying driver updates indiscriminately alongside operating system patches without specific testing or a clear need for the driver update is also problematic. Drivers are hardware-specific and can introduce new issues if not properly vetted, potentially causing hardware malfunctions or system crashes. This approach lacks the necessary diligence for effective patch management. Professional reasoning in such situations involves a systematic process. First, identify the type of update: security patch, feature update, driver update, and its criticality. Second, assess the potential impact of the update on the existing environment, including hardware and software compatibility. Third, plan a deployment strategy that includes testing, phased rollouts, and rollback procedures. Finally, communicate effectively with stakeholders regarding planned maintenance and potential impacts. Question 14. Implementation of a hybrid drive solution in a desktop computer aims to optimize system performance. Given a hybrid drive that combines a small, fast SSD with a large, slower HDD, which configuration best leverages the inherent capabilities of this technology for overall system responsiveness and efficient data access? Option A. Configure the SSD as a cache for the HDD, allowing the drive controller to intelligently manage data placement for frequently accessed files. Option B. Format the HDD as the primary boot drive and use the SSD as a secondary storage volume for less frequently accessed data. Option C. Install the operating system and critical applications on the SSD and use the HDD exclusively for storing user-generated data and media files. Option D. Partition both the SSD and HDD into separate volumes and utilize them as independent storage devices. The correct answer is A. Configure the SSD as a cache for the HDD, allowing the drive controller to intelligently manage data placement for frequently accessed files. Explanation: this scenario presents a professional challenge because implementing a hybrid drive solution requires balancing performance gains with data integrity and user experience, all while adhering to industry best practices and potential vendor guidelines, which are implicitly part of the CompTIA A+ framework's focus on practical IT solutions. Careful judgment is needed to select the most appropriate configuration for the intended use case. The correct approach involves configuring the SSD as a cache for the HDD, leveraging the speed of the SSD for frequently accessed data, while retaining the larger capacity of the HDD for bulk storage. This method optimizes read/write operations by placing critical system files and applications on the SSD, significantly improving boot times and application loading speeds without sacrificing overall storage space. This aligns with the CompTIA, a plus objective of understanding hardware components and their optimal configuration for performance and efficiency. An incorrect approach would be to use the SSD solely for operating system installation and the HDD for all user data and applications. While this offers some performance improvement, it fails to fully utilize the caching capabilities of a hybrid drive, leading to slower access times for frequently used applications and data that are not on the SSD. This is a suboptimal configuration that doesn't maximize the benefits of the hybrid technology. Another incorrect approach would be to partition the SSD and HDD separately and use them as independent drives. This defeats the purpose of a hybrid drive, which is designed to work in conjunction. It would result in the SSD being used for a limited amount of data and the HDD for the rest, without the intelligent caching mechanism that a true hybrid drive configuration provides. This is a misapplication of the technology. Finally, an incorrect approach would be to format the HDD as the primary boot drive and use the SSD as a secondary storage volume. This would negate the primary performance benefits of a hybrid drive, as the operating system and critical applications would reside on the slower HDD, leading to poor system responsiveness. The SSD's speed would be largely underutilized. Professionals should approach such decisions by first understanding the specific hardware capabilities of the hybrid drive, e.g., whether it's an SSHD with built-in caching, or a system where SSD and HDD are combined via software. Then they should consider the user's primary workload and prioritize performance for those tasks. Consulting manufacturer documentation and understanding the underlying principles of caching and storage optimization are crucial for making informed decisions that align with the goals of efficiency and user satisfaction, as expected in a CompTIA, a plus context. Question 15. Operational review demonstrates a user is reporting intermittent network connectivity issues on their workstation. The technician needs to quickly diagnose the problem using command line tools. Which sequence of actions best represents a systematic and efficient approach to troubleshooting this issue? Option A. Execute the kill-9-1 command to terminate all running processes and then restart the network services. Option B. Immediately restart the network adapter and then reboot the workstation to resolve the connectivity problem. Option C. Randomly change the IP address and DNS settings in the network configuration panel without checking the current settings. Option D. Execute hostname and uname to identify the system, then use ipconfig to check the IP address and subnet mask, followed by ps and top to review active processes, and finally kill a suspicious process if identified. The correct answer is D. Execute hostname and uname to identify the system, then use ipconfig to check the IP address and subnet mask, followed by ps and top to review active processes, and finally kill a suspicious process if identified. Explanation. This scenario presents a common challenge in IT support, diagnosing a network connectivity issue under pressure. The professional must quickly and accurately identify the root cause without disrupting critical services or violating security protocols. The challenge lies in efficiently gathering system information to pinpoint the problem while adhering to best practices for system administration and data privacy. The correct approach involves systematically using system information commands to gather relevant data. This begins with verifying the system's identity and network configuration. Commands like hostname and uname provide fundamental system details, while ipconfig on Windows or ifconfig on Linux/Mac OS reveal the current network interface settings, IP addresses, and subnet masks. If these initial checks don't reveal an obvious misconfiguration, the next step is to examine active network processes and their resource utilization using ps and top. This helps identify any rogue or resource-intensive processes that might be impacting network performance. If a problematic process is identified, the kill command can be used to terminate it, but only after careful consideration of its impact. This methodical, data-driven approach ensures that the diagnosis is accurate and that any corrective actions are targeted and justified, minimizing the risk of unintended consequences. This aligns with the CompTIA, a plus emphasis on efficient troubleshooting and understanding core system utilities. An incorrect approach would be to immediately attempt to restart network services or reboot the system without first gathering diagnostic information. This is a brute force method that can mask the underlying issue, potentially leading to recurring problems. It also risks interrupting services unnecessarily. Another incorrect approach is to randomly change network settings without understanding the current configuration or the implications of the changes. This can exacerbate the problem and introduce new issues, violating the principle of least privilege and potentially causing system instability. Finally, indiscriminately terminating processes without identifying their function or impact is a dangerous practice. It could lead to the termination of critical system processes, causing system crashes or data loss, which is a significant ethical and professional failure. Professionals should employ a structured troubleshooting methodology. This involves 1. Identifying the problem, 2. Establishing a theory of probable cause, 3. Testing the theory to determine the cause, 4. Establishing a plan of action to resolve the problem and implement the solution, 5. Verifying full system functionality and implementing preventative measures, 6. Documenting findings, actions, and outcomes. This systematic process, supported by the appropriate use of system information commands, ensures efficient and effective problem resolution. Question 16. During the evaluation of a user's workstation experiencing slow application loading times and prolonged file transfer durations, a technician is tasked with recommending a storage upgrade. The user explicitly states a desire for a significant improvement in speed for daily tasks and multimedia editing. The workstation currently has a SATA Roman 3 interface available on the motherboard. Which of the following storage interface types would be the most appropriate for this user's needs, considering the available motherboard interface and the user's stated performance requirements? Option A, NVMe SSD. Option B, SATA HDD. Option C, SATA SSD. Option D, external USB 3.0 flash drive. The correct answer is A, NVMe SSD. Explanation. This scenario presents a common challenge for IT professionals, balancing performance needs with compatibility and cost-effectiveness when selecting storage solutions. The professional challenge lies in understanding the nuances of different storage interfaces and their implications for system performance, data integrity, and future scalability, all within the context of the CompTIA A+ exam scope, which focuses on foundational IT knowledge relevant to U.S. regulations and industry best practices. Careful judgment is required to avoid recommending solutions that are either overspec'd, underspec'd, or incompatible, leading to wasted resources or system instability. The correct approach involves selecting the NVMe interface for the new workstation. This is the best professional practice because NVMe offers significantly higher performance than SATA, directly addressing the user's need for faster application loading and data transfer. NVMe utilizes the PCIe bus, allowing for much lower latency and higher throughput compared to SATA, which is limited by its ASI protocol. For a workstation demanding speed, NVMe is the modern standard. This aligns with general IT best practices and the CompTIA A+ curriculum's emphasis on understanding current hardware technologies and their performance benefits. There are no specific U.S. regulations directly dictating storage interface choices for individual workstations, but adherence to performance expectations and efficient resource utilization is an implicit professional standard. An incorrect approach would be to recommend a SATA SSD. While SATA SSDs are faster than traditional HDDs, they do not offer the same performance leap as NVMe. Recommending SATA in this scenario fails to meet the user's explicit need for speed and represents a suboptimal technical decision, potentially leading to user dissatisfaction and the need for an upgrade sooner than anticipated. This is a failure in professional judgment by not selecting the most appropriate technology for the stated requirements. Another incorrect approach would be to recommend a traditional hard disk drive, HDD, with a SATA interface. This is a significant performance downgrade from what the user requires and what modern workstations are capable of. It demonstrates a lack of understanding of current storage technologies and their impact on user experience, failing to meet the core requirement of faster application loading. Finally, recommending an external USB drive for the primary operating system and applications would be fundamentally flawed. USB interfaces, even USB 3.0 or higher, are designed for external peripherals and data transfer, not as primary internal storage for an operating system. Their latency and throughput are generally not suitable for the demands of an OS, leading to extremely poor performance and system instability. This approach shows a misunderstanding of the intended use and capabilities of different interface types. Professionals should approach such decisions by first thoroughly understanding the user's requirements and the system's intended use. Then, they should evaluate available technologies like SATA, NVMe, USB, based on their performance characteristics, compatibility, and cost. The CompTIA, a plus framework, emphasizes understanding these trade-offs to make informed recommendations that balance performance, budget, and user satisfaction. Question 17. System analysis indicates that a critical server is failing to boot, displaying an error message related to boot device not found. The server contains sensitive customer data. The technician's primary goal is to restore functionality with minimal downtime and ensure data integrity. What is the most appropriate initial course of action? Option A. Access the BIOS/UEFI to verify the boot order and attempt to boot from a known good diagnostic USB drive. Option B. Power cycle the server multiple times in rapid succession to reset hardware components. Option C. Immediately reformat the primary hard drive and reinstall the operating system. Option D. Physically remove and reset the server's RAM modules. The correct answer is A. Access the BIOS/UEFI to verify the boot order and attempt to boot from a known good diagnostic USB drive. Explanation. This scenario presents a common but critical challenge in IT support. Troubleshooting boot issues without disrupting critical business operations or violating data privacy regulations. The professional challenge lies in balancing the need for rapid resolution with the imperative to maintain system integrity and comply with established IT policies and potentially data protection laws. A technician must possess a deep understanding of how firmware settings influence the boot process and be able to diagnose issues systematically. The correct approach involves a methodical, non-destructive diagnostic process that prioritizes understanding the system's current state before making any changes. This begins with accessing the BIOS/UEFI to observe the existing boot order and other relevant settings. Documenting these settings is crucial for rollback and auditing purposes. Then, the technician should attempt to boot from alternative media, such as a USB drive containing diagnostic tools or an operating system installer, to bypass the potentially problematic internal storage. This allows for independent verification of hardware functionality and the integrity of the operating system installation, without altering the primary boot configuration initially. If the system boots successfully from alternative media, it strongly suggests an issue with the internal drive or its configuration, guiding further troubleshooting steps. This approach aligns with best practices for system administration, emphasizing data preservation and minimizing downtime through informed, step-by-step diagnostics. While specific U.S. regulations like HIPAA or SOX might not directly govern BIOS settings, the underlying principles of data integrity, security, and operational continuity are implicitly supported by these frameworks, which mandate responsible IT practices. An incorrect approach would be to immediately attempt to reformat the hard drive or reinstall the operating system without first verifying the boot order or testing with alternative boot media. This is a destructive action that risks permanent data loss and is not a diagnostic step. It bypasses the fundamental troubleshooting principle of isolating the problem. Another incorrect approach would be to arbitrarily change BIOS/UEFI settings without understanding their impact or documenting the original configuration. This can lead to further system instability, rendering the system unbootable and potentially requiring a complete rebuild. Furthermore, if the system contains sensitive data, making unauthorized or uninformed changes could inadvertently compromise data security or violate internal IT policies designed to protect that data. Professionals should employ a decision-making framework that prioritizes information gathering, systematic diagnosis, and non-destructive troubleshooting. This involves 1. Understanding the reported problem and its context. 2. Accessing system logs and firmware settings to gather initial data. 3. Formulating hypotheses about the root cause. 4. Testing hypotheses through controlled, non-destructive methods. 5. Implementing solutions based on confirmed diagnoses with a plan for rollback. 6. Documenting all steps taken and their outcomes. Question 18. Performance analysis shows a user is unable to log into their workstation due to a forgotten password. The user is distressed and needs immediate access to critical files stored locally on the machine. As a technician, you have been asked to resolve this issue promptly. What is the most appropriate and secure course of action? Option A. Utilize the operating system's built-in password reset utility or administrative tools to reset the user's password. Option B. Boot the system into a recovery environment and attempt to modify system files to bypass the login screen. Option C. Advise the user that the only solution is to perform a full operating system reinstallation. Option D. Create a new administrator account and use it to log in and access the original user's files. The correct answer is A. Utilize the operating system's built-in password reset utility or administrative tools to reset the user's password. Explanation. This scenario presents a professional challenge because it involves a conflict between user convenience and data security, which are both critical aspects of IT support. The technician must balance the immediate need for a user to access their system with the potential long-term risks associated with bypassing security protocols. Careful judgment is required to ensure that any action taken is both effective and compliant with established best practices and potential regulatory guidelines. Even if not explicitly stated in the CompTIA, a plus exam context, the principles of responsible IT practice are paramount. The correct approach involves utilizing the operating system's built-in administrative tools to reset the user's password. This method directly addresses the problem of a forgotten password by following the established security procedures of the operating system. It ensures that only authorized personnel, the technician in this case, acting on behalf of the user's request, can regain access, thereby maintaining the integrity of the user's account and the system's security. This aligns with the ethical responsibility to protect user data and system access from unauthorized use. Bypassing the password prompt by booting into a recovery environment and attempting to manipulate system files to gain access is an incorrect approach. While it might grant access, it circumvents the intended security mechanisms of the operating system. This action could potentially compromise the system's integrity, leave it vulnerable to further exploitation, and violate the principle of least privilege, as it involves unauthorized modification of system files. It also sets a dangerous precedent for future user requests, suggesting the user create a new user account with administrative privileges to access the original user's data is also an incorrect approach. This method not only fails to resolve the immediate issue of the forgotten password for the original account, but also creates a new security risk. It could lead to data fragmentation, confusion, and potential access control issues if not managed meticulously. Furthermore, it does not address the root cause of the problem and could lead to further complications. Finally, advising the user to perform a full operating system reinstallation to clear the forgotten password is an incorrect approach in this specific context. While a reinstallation would resolve the password issue, it is an overly drastic and inefficient solution for a forgotten password. It would result in significant data loss for the user, requiring them to reinstall all applications and restore their data from backups, which may not be readily available or complete. This approach demonstrates a lack of understanding of more targeted and less destructive troubleshooting methods. Professionals should approach such situations by first understanding the user's immediate need. Then, they should identify the most secure and efficient method to resolve the issue, adhering to established IT best practices and security principles. If unsure about the correct procedure or potential implications, consulting documentation or a senior technician is a crucial part of the decision-making process. The goal is always to restore functionality while maintaining the highest level of security and data integrity. Question 19. Stakeholder feedback indicates a need for enhanced server performance specifically for running multiple virtual machines concurrently. The IT team is evaluating CPU options and needs to determine the most appropriate feature set for this requirement. Which of the following CPU features is most critical for optimizing the performance of a server intended for heavy virtualization workloads? Option A. Support for a specific instruction set for video encoding. Option B. A very high core count without hyperthreading. Option C. Support for hardware virtualization and hyperthreading. Option D. Presence of integrated graphics. The correct answer is C. Support for hardware virtualization and hyperthreading. Explanation. This scenario presents a professional challenge because a stakeholder is requesting a hardware configuration that may not be the most efficient or cost-effective for the intended purpose, potentially leading to underutilization of resources or unnecessary complexity. The decision requires balancing stakeholder requests with technical best practices and understanding the implications of specific CPU features. The correct approach involves recommending a CPU that supports hardware virtualization and hyperthreading, as these features directly enhance the performance and efficiency of virtualized environments, which is often a key requirement for modern IT infrastructure. Hardware virtualization support, like Intel VTX or AMD V, allows the CPU to efficiently run virtual machines, reducing overhead. Hyperthreading enables a single CPU core to handle multiple threads concurrently, improving overall throughput for multitasking and virtualized workloads. Integrated graphics are a secondary consideration for a server environment unless specific display output is required, and their absence on a server-grade CPU is typical and not a detriment to virtualization performance. This approach aligns with best practices for server hardware selection, prioritizing features that directly address the stated need for virtualization performance and efficiency. An incorrect approach would be to recommend a CPU without hardware virtualization support. This would significantly hinder the performance of virtual machines, leading to a poor user experience and inefficient resource utilization, failing to meet the stakeholders' implied need for effective virtualization. Another incorrect approach would be to prioritize a CPU with integrated graphics for a server environment. While integrated graphics are useful for client machines, they are generally unnecessary and add cost/complexity to servers, diverting focus from critical server performance features like virtualization and processing power. Recommending a CPU with a very high core count, but without hyperthreading might seem beneficial, but it could be less efficient for highly threaded virtualized workloads compared to a CPU with fewer cores but hyperthreading, failing to optimize for the specific demands of virtualization. Professionals should approach such situations by first clarifying the exact requirements and expected workloads. Then, they should evaluate available hardware options against these requirements, considering the impact of specific CPU features like virtualization support and hyperthreading on performance and efficiency. Finally, they should present a recommendation that balances stakeholder needs with technical feasibility and cost-effectiveness, explaining the rationale behind their choices. Question 20. The control framework reveals that a critical business database experiences frequent small data modifications throughout the business day. The organization prioritizes rapid recovery in the event of a system failure. Which backup and recovery strategy best addresses these requirements? Option A, perform a full backup daily with daily differential backups. Option B, perform only incremental backups daily. Option C, perform a full backup weekly with daily incremental backups. Option D, perform a full backup daily, followed by incremental backups throughout the day. The correct answer is D. Perform a full backup daily, followed by incremental backups throughout the day. Explanation. This scenario presents a common challenge in IT support, balancing data integrity, recovery speed, and resource utilization, while adhering to best practices and potential regulatory requirements for data retention and availability. The professional challenge lies in selecting the most appropriate backup strategy for a critical database that experiences frequent, small changes throughout the day, where rapid recovery is paramount. Careful judgment is required to avoid data loss and ensure business continuity. The correct approach involves implementing a full backup strategy combined with frequent incremental backups. A full backup establishes a complete baseline of the data. Incremental backups then capture only the changes made since the last backup of any type, full or incremental. This strategy allows for the fastest possible recovery because only the last full backup and the most recent incremental backup need to be restored. This is ethically sound as it prioritizes data availability and minimizes downtime, which is crucial for business operations and customer trust. While CompTIA, a plus, focuses on technical aspects rather than specific legal regulations, the principle of ensuring data availability and integrity aligns with general IT best practices that underpin many compliance frameworks. Implementing only full backups daily would be inefficient and resource-intensive, consuming excessive storage space and backup time, especially for a large, frequently updated database. This approach, while ensuring complete data restoration, is not optimal for performance and resource management. Implementing only incremental backups without a periodic full backup is a significant risk. If the chain of incremental backups is broken or corrupted, restoring the data becomes impossible or extremely difficult, leading to potential data loss. This violates the fundamental ethical responsibility of ensuring data recoverability. Implementing differential backups daily would capture all changes since the last full backup. While better than only incremental backups for recovery speed, requiring only the last full and the last differential, it would still consume more storage and backup time than incremental backups for a database with frequent small changes, as each differential backup grows larger than the preceding one. This is less efficient than the combined full and incremental approach for this specific scenario. Professionals should approach such decisions by first understanding the criticality of the data, the acceptable recovery time objective RTO, and the acceptable recovery point objective RPO. Then, they should evaluate different backup types based on their impact on these objectives, as well as on storage, network bandwidth, and processing resources. A comparative analysis of backup types against these requirements, considering the nature of the data changes, will lead to the most effective and responsible solution.